The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video: Assumed quotient is a real quotient with a double-digit remainder. Let us take the previous example with a slight modification to demonstrate how the assumed quotient becomes the real quotient in the process of division and also get a double-digit remainder. Let us take the example 1766 divided by 23. Let us set the dividend 1766 in the right extreme of the abacus, that is 1 in the thousands column, 7 in the hundreds column, 6 in the tens column and 6 in the units column. Let us set the divisor 23 on the extreme left of the abacus. As the highest digit of the dividend 1, which is less than the highest digit of the divisor, which is 2, there is no need to skip a column in setting the quotient. That means the quotient should be set to the immediate left of the number 1. Now let us consider the first digit of the dividend, which is smaller than the first digit of the divisor, and therefore we have to take the first two digits, and in this case it is 17. Now ask, how many 2's in 17? We get 8. As a general rule, let us reduce 1 from this 8 and set 7 to the immediate left of the dividend. Now let us multiply 7 with the divisor 23 and subtract it from the dividend. 7 multiplied by 2 is 14, and therefore you have to subtract 1 from the thousands column and 4 from the hundreds column. For doing this, we have to clear 5 in the upper abacus and add 1 in the lower abacus. Now let us multiply 7 with 3, which is 21. That should be reduced from the dividend, that is 2 from the hundreds column and 1 from the tens column. Now we are left with the number 156 in the dividend. Now take the first two digits of the dividend, which is 15, by saying how many 2's in 15. There are 7 2's. Reduce 1 by applying the general rule and therefore set the number 6 as the second digit of the quotient, and it should be set to the right of the already set quotient 7. Let us multiply 6 with 23, that is 6 multiplied by 2, that is 12. That means we have to clear 1 bead in the hundreds column and then 2 from the tens column. That means we have to clear 5 in the tens column and add 3 in the same column. In the next stage, we have to multiply 6 with 3, which gives 18, and therefore we have to reduce 1 from the tens column and 8 from the units column. We cannot reduce 8 from the units column, and therefore we clear 1 bead in the tens column, and in order to compensate that, we have to add 2 in the units column. Now we are left with 8 in the units column and 1 in the tens column. 18 is less than the divisor 23, and therefore there is no adjustment necessary in the assumed quotient. In this case, our assumed quotient has become the real quotient. Look at the result part. In any double-digit divisor, the possible remainder may also be a double digit number, and therefore we should treat two right extreme columns as the places for remainder, and the one to the left of it is the column separating the quotient and the remainder. In this case, the remainder is 18, and the third column from right is the one which is separating the quotient and the remainder. Therefore, the result in this problem is 76 as the quotient and 18 as the remainder.